Have you ever thought about time, the thing we measure with the ticking of a clock? Does it move the same way for everyone? In our everyday life, it feels like time never stops or slows down. It always flows at a steady pace in one direction. But is this really true? Is time actually that simple and straightforward? The mystery behind this was revealed by a scientist who completely changed how we understand our universe, Albert Einstein. Many years ago, when science was still in the dark about so many things, Einstein introduced a theory that shook our understanding of time and motion. This theory was called special relativity. This theory says that time doesn't work the same for everyone. People at different places moving at different speeds experience time differently. What? Yes, the experience of time can be different for everyone. Now this might sound strange, but let's understand it with a simple example. Imagine your friend is standing on a railway platform and you're sitting on a train that's moving in a straight line at a constant velocity. The train windows are closed. You can't see anything outside. Now the laws of physics are the same for both of you. For your friend, they're standing still and you're in motion. But you, sitting in the train, can consider yourself to be still because your train's speed is constant. It's not getting faster or slower, and it's not changing direction. Now think if you throw a football inside the train. For you, that ball is moving at 20 kilometers per hour. But for your friend standing on the platform, the train is moving at 100 kilometers per hour. For them, that ball is now moving at 120 kilometers per hour, meaning your speed plus the ball's speed. Here's another interesting thing. If another person is running at 10 kilometers per hour in the direction of the train, for them, the ball's speed will be 130 kilometers per hour. This means one object's speed looks different to different people. That's why this theory is called relativity. Things are always seen in a reference frame, but the real beauty of special relativity is something else. The speed of light is always the same for everyone, whether they're still or moving. Let's understand this too with a simple example. You and your friend are standing face to face. Your friend has a torch in their hand. They turn the torch on and light reaches your eyes. You immediately measure its speed, about 300,000 kilometers per second. Now imagine you're running toward your friend at 10,000 kilometers per second and they turn the torch on again. Now you might think the light's speed should be 310,000 kilometers per second. But no, it will still be the same, 300,000 kilometers per second. This rule applies in every situation. Now a question comes up: if light's speed is always constant, then everything else, meaning space and time, must change to keep this balance. This is where the magic of special relativity begins. Now let's understand time with another interesting experiment. There are two countries, Country A and Country B. Both countries' leaders want to sign an agreement, and they want to sign at the exact same moment. A light bulb was placed in the middle, and the rule was made that they would sign when the light reached both their eyes. The first time this experiment happened in a still room. Both leaders sat at equal distances, and when the light turned on, both signed together. All good. But the second time they decided to do this experiment on a moving train. The same setup was done in the train. Now the leaders sitting inside were happy. They also signed at the same time. But people standing on the platform started arguing, because according to them, Country A's leader signed first. Why did this happen? Because when the light bulb turned on, the train was moving. Country A's leader was moving forward in the direction of the light, so it reached them first, while Country B's leader was in the backward direction, so the light reached them later. The speed of light was the same, but the distance became different. That's why for both of them, the definition of the same moment became different. This example helps us understand that an event that happens in one moment for one person can happen in a different moment for another, and this isn't an illusion but reality. Now think, if time itself is different for everyone, then how do we measure time? Is the ticking of a clock a true indicator? Let's talk about an amazing device here. The light clock. A light clock has two mirrors, and between them a beam of light moves up and down. When it goes up and down, that's counted as one tick. Now if this clock is still, the light moves straight up and down. But if this clock is in motion, like placed on a moving train, then the light beam doesn't move straight anymore. It travels at a diagonal path, meaning it has to cover more distance because the speed of light is fixed. It can't go faster, so covering more distance takes more time. This means that time moves slower in a moving clock. This is time dilation. But one interesting thing is that the person sitting in that train won't feel that time is slowing down. For them, everything is normal because they're moving along with the clock. Time dilation is only felt by those who are watching from outside. So can time really slow down? If a spaceship gets close to the speed of light, can time stop inside it? The answers to these questions are hidden in Einstein's unique theory, which showed that there's a special relationship between time, motion, and the speed of light, a mystery that shakes every person's thinking. So far, we've learned that when an object is in motion, especially at high speed like a train, airplane, or rocket, then time slows down for it. And this isn't imagination but scientific fact. Einstein didn't just think about this. He also proved it mathematically. But one question still comes up in people's minds. Have we actually seen this happen? Has this theory been proven in experiments? So now let's tell you about two very interesting and historical experiments that prove that time really can slow down and special relativity isn't just something on paper but a real truth. It was 1971. Two scientists, Haefel and Keating, did an experiment that made history. They took two identical atomic clocks. Such clocks that measure time very accurately, where the chance of error is almost zero. They left one clock on the ground and put the other clock on an airplane that was going to fly around the world. When that airplane came back after circling the Earth several times, both clocks were compared. What was the result? The clock that was on the airplane had fallen behind a bit, about 60 nanoseconds behind. This is a very small difference, but according to the airplane's speed, it was exactly the difference that Einstein's calculations had predicted. Now think, just by moving at high speed, the clock felt time slowly, and this made it clear that time can actually change according to speed, and this isn't an illusion but a measured fact. But this was an experiment with human-made clocks. Let's now talk about another experiment that nature itself put in front of us. It's called the muon experiment. Muons are a type of particle just like electrons, but their life is very short, just 2.2 microseconds, meaning 0.00000022 seconds. In such little time, this particle breaks down and disappears. Now think, when muons come from the height of the universe, like from space toward Earth, they have to pass through the atmosphere to reach Earth's surface. If we just look at their lifespan, they shouldn't have time to reach the surface. They should end halfway. But when scientists measured them on Earth's surface, surprisingly they found that many muons had reached there. How? The answer is time dilation. When these particles are traveling close to the speed of light, time slows down for them, meaning they feel like only 2.2 microseconds have passed, but for those watching from outside, they stay alive longer. This experiment proved special relativity at a natural level. Now just imagine, you and your friend are both the same age. You get on a rocket and go on a space journey, and that rocket is traveling very close to the speed of light. Now you travel for 6 months out in the depths of the universe and then return to Earth. For you, only 6 months have passed. But when you meet your friend, they're now a 40-year-old person. They say, "When you left, I was young. Now I've grown old," and you're shocked thinking, "For me, it was just a few months." This is called the direct experience of time dilation. And this is where the special relativity theory fully reveals itself. Now we've understood up to here that time can slow down because of speed. But could there be another reason? Does only speed slow down time, or does gravity also play a role? Actually, after special relativity, Einstein gave another deep theory called general relativity. In this, he explained that in places with very strong gravity, time also slows down. But that's another mysterious topic which we'll discuss in detail in later parts of this documentary. For now, if we talk about special relativity, it raises another question. If this theory is true, then how do our mobile phones, GPS systems, and satellites work? Does time dilation happen there too? The answer is yes, absolutely it does. Your mobile's GPS that gives you accurate location receives signals from satellites. But those satellites move at high speed compared to Earth and are very far from Earth, where gravity is a bit different. The clocks in those satellites run slightly faster than clocks on Earth. If we don't correct this small difference, the GPS would start making errors of several kilometers every day. So Einstein's theory isn't just true in theory, but is being used every day in our everyday life. Now think one person without any big lab, without any modern computer, just with their imagination, calculations, and deep thinking, presents this entire theory. What science accepts as truth today was once born in one person's mind, Albert Einstein. His thinking changed the way we see our universe. He taught us that now isn't the same for everyone. For some, time moves forward while for others it slows down. And this is just the beginning. The mysteries of the universe haven't ended yet. They've only lifted a few curtains so far. Moving forward, we'll learn how time and space are woven together and how we're all bound by the rules of this vast universe, whether we experience them or not. Now when we've understood that time isn't fixed and can change according to our position and speed, a new question arises before us. Is time a physical object that we can measure, or is it just a concept in our mind? This question might sound philosophical, but in science it's a very important question, because if time is different for everyone, then this now that we all experience isn't the ticking of some universal clock but a personal experience. Einstein said, "The distinction between past, present, and future is only a stubborn illusion." So does time actually exist? Or is it just a way to express the sequence of events? When we look at a clock, we feel time is flowing. But if you look at an atomic particle, there's no ticking there. Only events happen there. There's no sense of time. There are just particles, their motion, and their collisions. Now think, if a space traveler is standing on another planet millions of kilometers from Earth and is looking at the same sun we're looking at, then for them that present moment will be different because they're seeing the light coming from the sun with a few minutes delay. Here a new concept comes up: simultaneity, the feeling of happening at the same time. Special relativity tells us that simultaneous time isn't the same for everyone. An event that's happening now for me might not be happening now for you if you're in motion or at a different place. This idea can seem strange and uncomfortable for a normal person, because we've always believed that now is the same for everyone. But Einstein put a new truth in front of us, a truth that's as difficult to understand as it is amazing. Now let's take another example. This time let's remember a light clock again. This time we'll understand it in more detail. We make a clock in which a beam of light goes up and down between two mirrors. When this beam goes up once and comes down, we consider that 1 second. This light travels so fast that our normal clocks can't match its accuracy. Now when this clock is still, the light beam moves straight up and down and time seems normal. But when this clock is in motion, let's say it's on a train moving at 90% the speed of light, then the light can't move straight anymore because the clock is moving forward. So the light has to travel at a diagonal path, meaning it has to cover more distance. Now the speed of light always remains constant, meaning it can't go faster. So to cover more distance, it takes more time. And because we consider each up and down movement as 1 second, this means now 1 second has become longer. This is time slowing down, time dilation. It's exactly like someone slowed down your clock, but you don't even know because everything around you is moving at that same speed. Now you're thinking, if time can slow down, can it also stop? Scientists have found through calculations that if an object moves at 100% the speed of light, then time completely stops for it. That object would find time stopping. But here's a big question. Can any object, especially any human or massive object, actually reach the speed of light? The answer is no. And this is the most unique thing about special relativity. As you get closer to the speed of light, your energy keeps increasing, and when you reach the speed of light, that energy becomes infinite, and giving infinite energy to any object is impossible. That's why any object that has mass, whether it's a rocket, human, or atom, can't travel at the speed of light. But this doesn't mean we can't use this. Today's scientists use this theory to make very accurate clocks. GPS satellites, which we mentioned earlier, have time dilation correction done every day so that our mobile location remains completely accurate. A common part of our life rests on special relativity, and we're probably not even aware of it. Now the question comes up. If time can slow down because of speed and can also slow down because of gravity, can we time travel? Can we go to the future? This question has given birth to thousands of ideas in science, fantasy stories, films, and novels. But Einstein's theory says yes, we can go to the future, but going back to the past isn't possible. When someone moves very fast, like a traveler inside a rocket, time slows down for them. And when they come back, only a few months have passed for them, but many years have passed in the outside world. This is a type of future travel where you go ahead but stay behind compared to others. This isn't impossible, it has happened. For travelers in very high-speed spacecraft, time has slowed down, even if the difference is very small. So next time when you look at time on your watch, remember that time is ticking just for you. Someone else somewhere is experiencing that same moment differently. And this is the real beauty of the universe. It's not the same but different for everyone. So far we've learned about the relationship between speed and time. We saw how time, which feels like it's constantly flowing, is actually not fixed. It's not objective but relative. It depends on our speed and position. This knowledge is as shocking as it is beautiful. But the journey of special relativity doesn't end here. Now we move in the direction that opens up the depth of this theory even more. Spacetime, that concept which changed the way we understand the universe forever. First, let's understand what spacetime is. We've all heard that we live in three directions: length, width, and height. This is our physical world. But Einstein showed that time is also a fourth dimension, and combining all four creates a very large, invisible, and flexible structure that we call the spacetime fabric. Imagine a large stretched rubber sheet that you can gently pull, bend, and place some heavy objects on. As soon as you place a heavy ball on that sheet, it sinks downward and the surface around it also bends. Now if you place a small ball on that curved surface, it starts sliding toward the heavy ball. It feels like it's pulling. This is the real form of gravity. We used to think that gravity is an invisible force that pulls objects, but Einstein showed that gravity is actually the bending of spacetime. Any heavy object like Earth, the Sun, or a planet bends spacetime, and when another object comes into that bent space, it moves along that path, and this is when we feel the effect of gravity. So when we say the moon is bound in Earth's gravity, it means it's rotating in spacetime which Earth has bent with its mass. Now a very important question comes up here. If spacetime can bend, curve, and vibrate, can it also affect time? The answer is yes. This is the place where we slowly move from special relativity toward general relativity. Special relativity tells us that time slows down with speed, but general relativity teaches us that gravity can also slow down time. This sounds completely imaginary, but it's been proven many times in science. Now we'll tell you about a very famous experiment that will shock you. Imagine you placed one clock at the peak of Mount Everest and another identical clock at sea level. After a few months, both clocks were compared. Scientists found that the clock that was at high altitude ran slightly faster. How? Because at height, gravity is a bit less, meaning spacetime is bent a bit less, while at sea level, spacetime is bent more and time runs a bit slower there. This experiment revealed another mystery of general relativity: gravitational time dilation, meaning time slowing down due to gravity. Now you're thinking, does this have any effect on our life? The answer is every day, every moment. Our GPS satellites are hundreds of kilometers above Earth, where gravity is less than on Earth. Time runs slightly faster there compared to down here. At the same time, because of the satellite's speed, according to special relativity, time runs slightly slower. Both effects are opposite, but scientists balance both very precisely so that your mobile location is completely accurate. Now think, if this difference in time dilation isn't corrected, GPS would start making errors of several kilometers every day. So what once seemed like just a theory has now become the foundation of the most reliable technologies in our world. Now let's come back to our main question. Can time slow down? By now we've seen that time slows down because of speed special relativity. Time also slows down because of gravity general relativity. But is stopping time possible? Scientists' answer is still that if an object moves at the speed of light, time will completely stop for it. But the problem is that any object with mass can never reach the speed of light. Because the faster you move, the more energy you need, and by the time you reach the speed of light, you need infinite energy, and infinite energy is impossible for any machine, any device, any rocket. So does this mean time travel is just imagination? No, traveling to the future is scientifically possible. We've already talked about this, but going to the past is still a mystery which we'll discuss in the next parts of this documentary. Coming this far, we've seen that we can't see time with our eyes, but it exists everywhere. It's the foundation of our experiences, but its nature isn't what we thought. It's neither fixed nor universal. It's flexible, flowing, and can sometimes even bend itself. Now think deeply. Can you ever imagine a universe where time has no fixed direction? Where past, present, and future exist in the same frame? Hidden in such imaginations is the hint of our next topic, the block universe theory, where time isn't a flowing river but is considered a fixed structure. So far we've learned that time flows like a river flows, forward without stopping. Every second, every moment pulls us from the present toward the future. We can remember our past but can't return to it. We can think about the future but can't see it. This has been our understanding. This is also our experience. But now let's think something different, an imagination that science has taken very seriously. Block universe theory, a concept that says time neither flows nor moves forward, but time exists in its complete form already. Past, present, and future, all three together. Imagine you're reading a novel. On each page, some events are written, some at the beginning, some in the middle, and some at the end. When you read the first page, you're in the present. But that last page which you haven't read yet, it's also there in that book itself in front of you. It hasn't disappeared. You just haven't read it yet. Block universe applies this same idea to time. According to this theory, the entire universe is a huge four-dimensional block where time is the fourth dimension, and in it every moment, every second already exists. Just like we can go from one place to another, similarly we can imagine different points in time. Only our consciousness, our experience, keeps moving while stuck at a point called now. According to this idea, we're not moving forward in time. We're just in a fixed frame and all other frames are frozen around us. The past hasn't been erased, it's still there. The future isn't uncertain, it also exists right there. So the question comes up, if past, present, and future all exist at the same time, then why do we experience them separately? The answer is hidden in our consciousness, meaning that part of our brain that experiences, that remembers, and that imagines the future. We consider our present experience as truth because our consciousness is seeing that frame. All other frames exist but are outside our vision. Some scientists believe that just like we watch a film frame by frame, similarly our consciousness experiences time moment by moment. But all those frames are already recorded. They all already exist. Now think, if you're in a universe where every event is already decided, does this mean something like fate really exists? Are the decisions we make already decided? Is the direction of our life, our choices, our thoughts, all written in some page of this block universe beforehand? This question brings science to the door of philosophy. Block universe not only says time is frozen, but also presents the idea that our free will might also be an illusion. We think we're making decisions, but it's possible those decisions are part of that time frame, a part we can't change. This can be a scary thought, but also very inspiring, because if the future already exists, we can move toward it fearlessly, and if the past also hasn't gone anywhere, then it never separated from us. It's still part of our existence. Now the question is there any scientific proof of this block universe theory? The direct answer is not yet. This theory is completely based on Einstein's general relativity, and the calculations used in it support this idea. But proving it experimentally is almost impossible because we can still only see now, not yesterday or the day after tomorrow. Still, many physicists and philosophers believe that block universe is the real nature of our universe. This theory has connected the boundaries of science with philosophy. Where special relativity showed us that time isn't the same for everyone, Block universe told us that maybe time hasn't gone anywhere but is always there, fixed, calm, and completely present. This idea changes our thinking. Now when you next think of an old memory, when you see some dream of the future, know that that memory and that dream both exist somewhere in that same block of your existence. You're just not experiencing them right now. Now our journey turns toward another mystery, a question that has come to the mind of every era, every culture, and every scientist. Can we go back in time? Can I go to the past and fix my mistakes? Can I see a glimpse of the future so I can make better decisions today? Is a time machine really possible? These questions haven't echoed only in imagination but also in the deepest corners of science. And this is our next journey: time travel, the mystery of traveling through time. The concept of time travel wasn't born first in science fiction stories, but in our philosophical thoughts. In ancient Indian scriptures and Greek philosophy, and even in some religious texts, time was seen in a flexible form. But in the modern age, when science considered time a physical dimension, time travel became not just imagination but a calculable possibility. So let's first clarify, is time travel possible? We'll divide the answer into two parts. 1. Future travel possible and proven. As we've understood in previous parts, both Einstein's special relativity and general relativity say that time is a relative experience. If an object or person moves very fast, especially close to the speed of light, time slows down for them. Meaning if a space traveler travels in a vehicle that moves at 99.9% the speed of light and travels for only 5 years, when they return to Earth, 50 or 100 years will have passed here, meaning that person has reached the future. This isn't imagination but a fact proven by scientific calculations and experiments. GPS, satellite clocks, and astronauts' biographies confirm this. So going to the future is completely scientifically possible. We just need extremely advanced technology and energy for it. But now comes the real question. 2. Past travel possible or just fantasy? This is the place where science gets confused, philosophers are shocked, and imaginations start jumping. Can we return to the past? Can we change our mistakes? Can we relive those moments that are now just memories? Science has given several theories on this topic, and some of them are very interesting. Wormholes, shortcuts in spacetime. The way Einstein's general relativity describes spacetime as something that can bend, curve, and stretch. From that came another amazing idea: wormhole. Now imagine the universe is a large paper, and you have to reach from one corner of this paper to the other. Usually you'd cross that whole page, meaning it would take time. But if you fold that paper and bring both edges together, you can reach the other side directly without covering the distance. This is a wormhole, meaning a tunnel that connects two different points of spacetime, like cutting a film scene and reaching directly to the final scene. Now if we could make a wormhole where one end is in the present and the other in the past, could we go through it to the past? Theoretically, yes. But in reality, creating wormholes and keeping them stable is so difficult that with today's technology and energy limits, it's impossible. To keep these wormholes open, the type of energy needed is called negative energy, which isn't completely under science's control yet. Time travel and paradoxes. Now imagine you somehow go to the past and accidentally kill your own grandfather before his marriage. Now the question is, if your grandfather didn't survive, how were your parents born and how were you born? But if you weren't born, then how did you go to kill your grandfather? This is called the grandfather paradox. This logic tells us that going to the past might be theoretically possible, but it can have such tangled consequences that solving them is almost impossible for human intellect. Some scientists point to the many worlds theory to avoid this, which says that when you go to the past and make a change, you create a new universe branch, an alternate reality, where events start happening differently from that point. Meaning you don't change your own universe but start a new one. This theory is one of the most mysterious parts of science, connected to quantum mechanics, which we'll understand in detail ahead. Mental time travel, your memories and premonitions. Now stop and think, every time you remember your old memories, are you really returning in time? No, but your brain relives that experience. Happiness, pain, excitement, fear, everything. Science believes our brain is also a type of time machine in which, without physical movement, just with your consciousness, you can relive time. Similarly, sometimes we get a hazy glimpse of the future, which some people call intuition or premonition. Though all this isn't physical time travel, it shows that time isn't just flowing outside but also inside us. Now our next journey will take us into even deeper depths where we'll see how quantum mechanics, a science that rules the world of particles, sees time, and then we'll understand what time really is and why we haven't been able to fully understand it till today. We've now looked at time through the lens of speed, gravity, and relativity. We learned that time doesn't flow like a river, but behaves like a mysterious illusion. Sometimes slow, sometimes fast, and sometimes it completely stops. But now we're entering that branch of science which is considered the strangest, most complex, and most revolutionary: quantum mechanics. This is the world that tries to understand the activities of atoms and even smaller particles, where rules change, normal logic fails, and truth sometimes turns into probability. And the most shocking thing is that in this quantum world, time isn't what we understand. The quantum universe where particles can be in two places at once. First, let's talk about an experiment counted among the most mysterious experiments in science history, the double-slit experiment. In this experiment, scientists made two small holes in a screen and released a particle like an electron or photon one by one in front of them. Now you'd think the particle would go straight through one hole and make a dot on the screen, right? But when this was repeated many times, the pattern that formed was like waves, like ripples form in water, meaning the particles released one by one were also interfering with each other, as if they decided to pass through both holes at once. And when scientists tried to observe the particle, meaning to know which hole it went through, that wave-like behavior disappeared and the particle behaved like it only went through one hole. This created a mystery. When we're not watching, the particle is a wave, a probability, and when we're watching, it becomes a definite particle. Does this mean our observation itself changes reality? And what's its connection with time? Quantum physics and time, a chaotic relationship. In the quantum world, time is a strange element. In many quantum equations, time doesn't even exist. Yes, you heard right. In our everyday world, Newton's physics says that to know an object's position, we need to know its motion and time. But in quantum equations, you only see probability, the probability of a particle being at a certain place, and there's no clear place for time there. A famous physicist, Carlo Rovelli, said that time isn't part of fundamental laws but is a product of our limited experience, meaning time might be an interpretation of our brain, not of reality. Meaning at the quantum level, now and then, have no fixed meaning. Events happen there when they're measured, meaning when some consciousness or device observes them. Is time an illusion? If time has no place in quantum equations and in Einstein's general relativity time can be bent and slowed, is it possible that something like time doesn't actually exist? Many scientists are now starting to believe that time might be an emergent property, like temperature. For example, a single molecule has no temperature, but when millions and billions of molecules come together, their average behavior is called temperature. Similarly, maybe for individual particles time has no meaning, but when billions of particles come together to form an object, being, or consciousness, then an experience like time is created. So what if time is just a human experience and nothing actually passes in the universe? Everything is just a probability that our consciousness experiences. This idea is as deep as it is shocking. Quantum entanglement and time's independence. Now we come to the strangest but most proven idea of the quantum world: quantum entanglement. When two particles are entangled with each other through a special process, they connect in such a way that a change in one particle immediately shows effect in the other particle, no matter how far it is. Now this might sound ordinary, but here's something weird. This effect is beyond time's limit. Meaning if one particle's change happens now, the other particle will react immediately without any signal, without any time passing. How is this possible? Some scientists believe this makes time a local experience, meaning maybe time isn't the same everywhere and maybe some events are independent of time. From here, a new hypothesis is born that time isn't a universal clock, but each particle has its own time. Now we've reached a point where physics, philosophy, and consciousness start getting intertwined. Time isn't just the hand of a clock anymore. It has become the universe's most profound and most personal mystery. So is time actually something, or is time just us? Are we the consciousness that puts these events in a sequence and calls them time? The answer to this question might be found in our next section when we enter causality, that law of cause and effect hidden behind every event, and maybe which is bigger than time itself. In our journey so far, we've seen time from many perspectives. From speed to gravity, from the quantum world to block universe. We felt that time isn't what school books taught us, but is much more mysterious, flexible, and a personal experience. But now we're moving toward a principle that's more fundamental than time's existence itself: causality, the law of cause and effect. So let's first ask a basic question. If time exists, does it have a direction? Does time always move from past to future, or can it go backward too? Our experience says time's direction is one way. We can remember the past but can't change it. We can guess about the future but can't see it. But for scientists, this question becomes quite complex. So who determines this direction? The answer is causality. Causality says that behind every event there's a cause. Every action has a reaction. If you drop a glass from a table, it will break. But have you ever seen a broken glass join itself and come back on the table? No. This doesn't happen not because physics laws don't allow it, but because the direction of cause and effect can't reverse. Meaning we recognize time's direction by its effect. In scientific language, this is called the arrow of time. And this arrow always moves in one direction, from cause to effect. Thermodynamics and time's direction. Now let's understand this idea with a scientific example from the second law of thermodynamics. This law says that in any closed system, entropy, meaning disorder, always increases. For example, imagine you pour coffee in a cup and add milk to it. At first, milk and coffee are separate, but slowly they mix and become uniform. This mixture never separates on its own again because doing so would decrease disorder, which is against nature's laws. That's why we experience the past as organized and the future as disorganized. This is the principle of entropy, which says the universe's natural flow is in one direction, and that direction becomes time's direction. So when a scientist says time is irreversible, they're actually saying entropy never decreases, and because of this law we don't see time going backward. Can causality be changed? Now from this depth another question emerges. If the cause of an event is removed, can that event happen? For example, if a light turns on without any cause, this law would break. But we've never seen this till today. Without cause, there's no effect, and this is causality's power. But in the quantum world, some events happen that challenge this law. Events that are based on probability. There's no one definite cause, but there can be many possible causes. For example, when a radioactive atom breaks, it's not decided beforehand when it will break. It can just be estimated that after some time its probability of breaking is higher. Here the line between cause and effect becomes blurry. That's why some scientists of quantum physics believe causality also isn't a fixed law but a probabilistic property, a statistical pattern. Can the future be a cause? Now think, if cause is always in the past and effect in the future, can this law reverse? Can it ever happen that a future event influences a past event? Some scientific experiments, like the delayed choice experiment, have shown this possibility that a decision taken in the future can affect the nature of an event that has already happened in the past. This sounds very confusing, but its meaning could be that in the universe, time's direction isn't as clear as we think. This idea takes us to another amazing theory, retrocausality, meaning reverse cause and effect, where cause and effect can be anywhere in time's stream, not just in one direction. But till now, this is just a theoretical concept. It hasn't been completely proven by experiments yet. Still, it forces us to think that time's arrow might be an illusion. Consciousness and causality. Now let's look at our experience. We make decisions, then see their results. This seems straightforward and intuitive, But if block universe is true, every decision, every result is already decided. So are the decisions we're making not really made by us, but we're reading a script, a fixed cosmic screenplay? This question takes us beyond time into the depth of consciousness. Because if causality's direction is fixed and time already exists, maybe our experience itself creates time. Meaning this cycle of cause and effect is running inside us, and the universe is shaping according to it. Now our journey reaches another deep turn. Did time have a beginning, or was it always there? This question is connected to the universe's origin, and the next section will take us to that amazing moment when time opened its eyes for the first time. We've all asked ourselves this question at some point. When did time begin? Was time always there? Or did time also have a birth? This question isn't just of science, but is rooted in philosophy, religion, and our existence. When we chase this question going back into the universe's history, we reach a moment that science has named the Big Bang, that initial explosion from which our entire universe and possibly time itself was born. What was there before the Big Bang? This question is as straightforward as its answer is complex. For years it was believed that the universe always existed, meaning infinite and unchanging. But in the 20th century, when scientists measured the motion of galaxies, they found a shocking fact. All galaxies are moving away from each other. This meant the universe is constantly expanding. Now if we reverse this expansion, meaning wind time backward, we find there was once a moment when the entire universe was contained in an extremely dense, hot, and small point. This point was of infinite heat and density, and from this happened the Big Bang. And the special thing is, this is the moment when time's beginning is considered. Why? Because before the Big Bang, something like time didn't exist. There was no before or after, just void or maybe something beyond that. This is beyond our mind's thinking because we always think of everything inside time. But before the Big Bang, there was no inside or outside because space itself was born at that moment. Meaning before the Big Bang, there wasn't nothing, but there was no before itself. Time's birth, not just energy, but experience too. When the Big Bang happened, not just energy, particles, and the universe expanded. Time itself started expanding. This might sound strange in common language, but Einstein's general relativity taught us that time and space aren't two separate things, but together they form spacetime. When the universe expands, spacetime expands. When the universe expands, spacetime expands. This means new moments keep getting created. Time is born along with the universe, growing and spreading. So scientists say the Big Bang wasn't just an explosion in space, but an explosion of space and time itself. Before that, asking what was there is like asking what's north of the North Pole. The question itself loses its meaning. Can time end? If time had a beginning, can it have an end? This question is as fascinating as it is terrifying. Some scientists believe that just as time was born, it can also die. There are several theories about how the universe might end. The Big Freeze, where the universe keeps expanding forever. All stars burn out, all energy disperses, and everything becomes cold and dark. In such a universe, there would be no events, no motion, no change. And if there's no change, can we say time still exists? Or would time also freeze there? The Big Crunch, where the universe's expansion stops and everything starts coming back together. The universe collapses back into a single point, just like it started. And in that moment, space-time itself would compress and time would end. The Big Rip, where the universe's expansion becomes so fast that even atoms get torn apart. In this scenario too, the structure of spacetime would break and time would end. These aren't just imaginations, but possibilities that science is seriously considering based on observations and calculations. Time, consciousness, and meaning. Now let's come back to ourselves. We humans who live in this universe, who feel time every moment. For us, time isn't just a physical dimension. It's the thread of our memories, our hopes, our relationships. When we say time is passing, we mean our life is moving forward. When we say we don't have time, we mean we can't fit more experiences in our limited existence. So time isn't just something we measure. Time is something we live. And this is where science meets philosophy and spirituality. Because when science tells us time can slow down, stop, or even not exist, then we have to ask ourselves, what are we? Are we just bodies made of particles moving through spacetime? Or are we consciousness that experiences time and perhaps creates it? Some spiritual traditions have always said that time is Maya, an illusion, that the eternal now is the only truth. Quantum physics and block universe theory are now showing us that maybe this ancient wisdom wasn't wrong. Maybe time isn't outside but inside us. Maybe we are time, the river of time and the ocean of existence. Throughout this documentary, we've traveled through the mysteries of time. We saw how Newton's absolute time was broken by Einstein's relativity. We learned that time can stretch and compress. We discovered that past, present, and future might all exist simultaneously. We explored how quantum mechanics questions time's very existence. We understood how causality gives time its direction. And we reached the boundaries of the universe where time was born and where it might end. But after this entire journey, one truth stands clear. Time is the greatest mystery of our existence. It's not just a number on a clock. It's the fabric of reality, the stage where the drama of existence plays out, and perhaps the most intimate part of our being. Every moment you're living right now, this very second as you're listening to these words, is unique and unrepeatable. It will never come back. And that's what makes it precious. Whether time is an illusion or the most fundamental reality, one thing is certain. We live in time, we feel time, and our existence is woven into its flow. So when you next look at a clock, don't just see numbers. See the universe's heartbeat. See the dance of particles. See the bending of space-time. See your own consciousness creating reality moment by moment. And remember, you're not just in time. In a very real sense, you are time. The journey of exploring time never truly ends because every answer opens up new questions. Scientists are still working to unite quantum mechanics with general relativity. They're searching for a theory of everything that can explain how time works at all scales, from the tiniest particles to the largest structures of the cosmos. Perhaps one day we'll fully understand time, or perhaps time will remain forever mysterious, always one step ahead of our comprehension. But that's the beauty of science and of existence itself. The mystery never ends. The questions keep calling us forward, and as long as we're curious, as long as we're wondering, we're truly alive. Thank you for joining us on this journey through time with Mr. Sleepy Science. May your moments be meaningful, your experiences rich, and your curiosity endless. Because in the end, time isn't about how much we have, but what we do with it. Good night, and may you dream beyond time itself.